All right. In section 6.1, guys, and 6.2, we found interval for the mean, the population mean. And the interval, the confidence intervals were like that, X bar minus E and X bar plus E. And we learned how to find those intervals, the lower bound and the upper bound, using the calculator and doing it by hand. If you're doing it by hand, I showed you how to find E, and then whatever X bar he gives us, we subtract E from X bar, and then we add E to X bar, and we get the interval, and that's called the confidence interval for the population mean average. Now, there is a confidence interval for population proportion. And let me tell you what we mean by population proportion. Proportion, guys, means percent. For example, if I wanted to find out the proportion of the percent of students who eat breakfast before they come to school in the morning, I want to find the proportion of students. I want to find a confidence interval for that. Well, I could ask you, I have 17 or 18 students now. I could ask you, how many of you eat breakfast? You guys, would you want to probably answer this question in the chat, or I'll just make it up? So let's say there's 17 of you today, and I ask you how many of you eat breakfast. And let's say 5 students said that they ate breakfast before the class started. So can you guys tell me, how do I figure out the percent of students in my class who ate breakfast? How do I do that? I have 17 total, and I have 5 who said yes, they ate breakfast before they came to the class. What do I do, guys, to find the percent? I divide 5 by what? By 17. Let's divide 5 by 17 and see what the answer is. And I'll show you where we're heading to after we do this. 5 divided by 17, 29%. So 0.29. If I change it to a percent, guys, which is 29.4%. Now, here's the question. Can I conclude, and I say on average, that the percent of students at Henry Ford College who eat breakfast before they come to school is 29.4%? Well, the answer is no, guys, because I only surveyed 17 students, and I have probably 10,000 students at Henry Ford College. So I don't think this percent will reflect on the actual percentage of students who eat breakfast before they go to the college. So, but what is the actual percentage? We don't know what the actual percentage is. In order to find out the actual percentage, you have to ask every single student. But instead of finding the actual percentage, guys, we can find an interval that has a lower percentage, a higher percentage, where we suspect the true percentage of students who eat breakfast before they come to the college is between those two values. And this interval, you know, the true percentage of students who eat breakfast before they come to college could be lower than 29.4 and could be higher than 29.4, and it could be 29.4. That's all the possibilities. So that's why the interval will be 29.4% minus something and 29.4% plus something. And that something, guys, is called the margin of error E. So there is also a margin of error for the proportion. So a proportion is different from the mean. The mean is a value, is a number. A proportion is a percent. And that's an example about the proportion. Now, what do we call the 29.4%? 29.4% is called the proportion from the sample. It's a sample proportion. This is, we know, guys, I have 17 students. I ask 5 of them. 5 over 17 is called the sample proportion. And in statistics, they call it a p-hat. So p hat is 5/17. What we need to find a confidence interval for is the population proportion. And the population proportion has a simple, guys, p. So we need to find an interval for the population proportion. So what is the population proportion of students at entire Henry Ford College who eat breakfast before they come to school? It's not going to be one number. It's going to be between two numbers. One is called the lower bound and one is called the upper bound. In section 6.2, guys, we wrote the mean like this. X bar minus E and X bar plus E. Okay, let me show you how we're going to change this one to make it fit in section 6.3. Then we put section 6.3. We're doing proportion. So this is going to change to P. This is going to change to P hat minus E and P hat plus E. P hat, guys, you will be given. It's in the sample. He will give you P hat to begin with. So this is, we know already. All I need to show you guys how to find E, just like we did in the previous sections. Now, what was the formula for E in the previous sections? It was this. Sigma over square root of n. We're going to tweak E. It's going to be a different formula that we're going to be using to find the margin of error for the population proportion. My E for this section is going to be this. And you will be given all those formulas if you are to use them. However, you're going to see later that we don't need even the formula on the calculator when we perform a confidence interval for the population proportion. So ZC is the critical value. This is exactly the same value that we found in section 6.1. And just to remind you guys, I asked you to memorize the critical value for 90% confidence level. It was 1.645. The critical value for 95% confidence level, it was 1.96. And the critical value for 99% confidence level, it was 2.576. So these are the three values I ask you to try to memorize. And they are available at the bottom of the table as well, guys, just to show you here. Watch, they're right here. 1.645. I wouldn't memorize the 80%. It's not very popular. 90, 95, 99, 2.575, or 6, it doesn't matter. All right. So what I'm going to do now, I'm going to walk you through an exercise in how to find the confidence interval for the population proportion by hand. And then we're going to do this using technology. So have your calculator handy. So now you have an idea that the proportion should be between P hat minus E and P hat plus E. P hat minus E is called the lower bound of the interval, and P hat plus E is called the upper bound of the interval. And I'll give you an example, guys, of the interval for proportion. During the previous election, you've seen a lot of polls on the TV with like the news trying to broadcast or predict, you know, just the percentage that someone who's running for election would get. And then you would see on TV that they say, this person might get 59%. And then you see at the bottom of the screen, margin of error plus or minus, let's say 5%. And the 59%, guys, is the P hat. And the plus or minus 5% is the margin of error for your information. So this is a P hat, and this is the margin of error. And how do they figure out the interval? It's 59 minus 5, which is 54, and 59 plus 5 will be 64. So the proportion is between 54% and 64%. A lot of people who watch TV and watch the polls don't understand what the plus or minus 5% mean, and that's why they try not to explain it on the TV. They don't say confidence interval because they know a lot of people don't get it. All they get is just give you this one, and they give you the margin of error with the hope that a lot of people would understand what the margin of error means. So when you see that they're predicting that someone will get 59%, of the votes, it's not exactly 59%, guys. It's a 59% minus 5 all the way to 59% plus 5. It could be any of the values in between 54 and 64. And now, since you're learning confidence interval, now you understand what that means. So we're going to do an exercise and show you how to proceed from there. Okay, section 6.3. We're going to construct confidence interval for the population proportion P. So it is called P. And before I get to that, I'm going to define P hat. P hat is X over N, where X is number of successes and N is the sample size. Just like when I say, I ask you, how many of you eat breakfast? 5 said we eat breakfast. This is called the number of successes. And N is the sample size, which is 17 students. So P hat is X over N, and P hat is called 1-point estimate of P. And P, guys, is called the population proportion. We will never know the population proportion, guys. We can estimate it, but we don't know it. Because in order to know the population proportion, you have to survey every single member of the population, which is not possible most of the time. Okay. In order to find a confidence interval for the population proportion, guys, there are 2 conditions that you have to do. We have to verify that N times P hat is greater than 5, and N times Q hat is greater than 5. Let me ask you guys, if P hat is 30%, do you guys know how to find a Q hat? Remember, P is a probability of success and Q is a probability of failure. So if P hat is 30%, can a student tell me what Q hat would be? Any answers? Let's see in the chat. Yeah, 70%, exactly. Because they should add up to 100%. So remember, guys, P hat plus Q hat is called 1. It's always 1. So the probability is going to be sunny today is 90%. The probability that it's not sunny today is 10%. How did I know that? I didn't do any magic. I just subtract 9% from 100% and I get 10%. All right. Let's do an exercise, guys, and show you how to do this. You will see it's not difficult at all. Now, how would you know now if the question is about finding confidence interval for the mean or confidence interval for the proportion? It will say it clearly, guys. The first 2 sections about the mean, this one is about the proportion. And watch. A survey of 500 non-fatal accidents, that's N. The big number is always N, guys. Showed that 142 involved uninsured drivers, that's X. So he will give you always 2 pieces of information, the number of successes and the sample size. So 142 is X. Construct a 99% confidence interval. C is 99% confidence interval. Look, guys, what it says. For the proportion of fatal accidents that involved uninsured drivers. Okay, so he says he wants a confidence interval for the proportion. Okay, state the value of the sample size. N is 500. I'm gonna walk you in the guided notebook. That's why it's called the guided notebook in steps. And C is 99%. Once you guys identify this right here, you're ready to use the calculator because the calculator will ask you for N, for X, and for C. It asks you for those 3 values. Verify the condition of the test. I like it to cross this off, guys. And it's actually MP hat greater than 5 and NQ hat is greater than 5. In another book, they use this condition, but for this book, it's this. Okay, let's verify if they're bigger than 5. Now, maybe you would ask me a question, what happens if one of those is not bigger than 5, then you don't do the test. But usually, guys, when I ask you to perform the test at the confidence interval, then you're gonna find out that they are bigger than 5 for sure. Okay, what is n? First of all, we need a p hat. P hat, guys, is x over n, which is 142 divided by 500, and which is gonna be 0.284. And let's find the q hat. Q hat, guys, is going to be 1 minus 0.284, which is 0.716. Okay, now I think I can verify. 500 times 0.284. Just use your calculator, multiply them, and see what you get. If you get a number bigger than 5, then you're good. 142. When you do your homework online, it might ask you to state what this number is and select bigger than 5. And now NQ hat, guys, which is 500. Definitely it's bigger than 5 as well. Okay, I'm gonna do this. 500 times 0.716. I got 358, guys. Bigger than 5. Okay. Find the critical value ZC using table 4 or using inverse norm. Well, I just listed them, guys. Can someone tell me what ZC for 99% confidence? You should know them by now. That's a 99%. Would a student tell me what do you think the value is? I know them by heart.
2.575.
You got it. Okay, now find the margin of error, which is 2.575 times. I will give you this formula if I ask you to do this by hand, guys. So P hat, which is 0.284, Q hat, which is 0.716. And again, guys, Q hat is 1 minus P hat, divided by the sample size, 500. And I'm gonna bring the calculator now under the screen because you have to be very careful in how to plug this into your calculator. Watch. Let's do it together. So it's gonna be, put 2.575 first. And I will go slow with this one, times a square root. For the square root, guys, just press the second key and then x squared right here. And put 0.284 times 0.716 divide. Here's a division sign, guys. $500. And look, how do you exit the square root, guys? Just with the arrow, right arrow key right here. Okay, you can see it. Enter. Okay. Let's do 3 decimal places, 0.052. And we're done, guys. Once you find E, you're gonna see we're almost done. Watch. That should be a P. It's a mistake from my side. I just copy and paste from one section to another. Okay. P hat, you already know. It's X over N, 0.284. Minus E, which is 0.052, less than P, less than P hat 0.284 plus 0.052. So P is between. Okay, let's do the subtraction. And then you will see the calculator, guys. You're gonna love how this is done with the calculator. So I got 0.232. Oops. Yeah. And then for 0.284 plus 0.052, I got 0.336. We will use the calculator in the second. Let me show you the interpretation, guys. How do you interpret this? With 99% confidence, you have to tell a reader, guys, that you're not 100% confident. You have to say the level of confidence. With 99% confidence, you can say, or we can say, that the true proportion, not the true mean here, it's a proportion of, I'll just copy and paste from the top, guys, right here. The true proportion of fatal accident that involved uninsured vehicles is between, usually for a reader, guys, it's nice to not to put decimals, change it to percent. It's easier for people to absorb when you have them as a percent. So what would that be as a percent? Is between 23.2% and what? And 33.6%. And that completes the problem. So you're saying in general, the percent of fatal accidents that involved uninsured vehicles could be as low as 23%, as high as 33.6%. Now, which one is the true one? We don't know. It's anywhere in between those two values. And that's not with 100% confidence, with 99% confidence. If I ask you to do a 95% confidence, guys, the interval will be narrower, but your confidence level goes down. If I ask you to do a 90%, it will be even narrower, but the confidence level will go down. So that's a complete question in this section. Now I'm going to show you how to use the calculator. Using TI calculator. Go to stat, tests. I'm just gonna write them down and then I demo that, and go to one prop Z interval. Enter X, enter N, enter C, and calculate. These are the steps, and let's do them together, guys. And my X here is the 142, my N is the 500, and the C is the 99. The mistake that students make, they mix the X and N, and the calculator will halt, will not do anything. Remember, X is a number of successes, and N is the sample size. Sample size must be the biggest one. Okay, ready to see how this is done? Okay, so stat, I said tests, I said one proportion interval, not z-test, interval. So you have to keep going, guys. Here you go. It's letter A. One prop z interval. Enter. Okay, X, 142. Look how easy it is. 500. 99, and hit calculate and watch, guys. Here's the interval. Does it match with what we did? Yes. 232, 33, and if you round this to 3 decimal places, will be 0.336. Exactly what we did, guys. That's the interval. Not only the calculator will give you the interval, give you p hat, and will confirm that the sample size was 500. Any questions? That's how you find the confidence interval for the proportion. We're going to do some more in a little bit, but just to thought to explain that to you in details. So that's a very, very good problem. It reflects on all the questions with confidence interval. Okay. Number 6. Now you have this formula, guys. This is called a formula. Any formula that has variables, equation that has variables is called a formula. This is, we have E on the outside. If I retweak this formula and I want to find N and put N on the outside, your formula will be like this. So sometimes he doesn't give us the sample size and he asks us to find the sample size. If he asks us to find the minimum sample size, we're going to be using this formula for N, which is P hat Q hat ZC over E quantity squared. So we're going to do an exercise and how to, and again, guys, I want to ask you to memorize this formula. I will provide this formula. And if you want to write it down on your note, 3 by 5, that's fine, but you will have a list of all the formulas that you need. So a researcher at a major clinic wishes to estimate the proportion of the adult population of the United States that has a sleep deprivation. Why it is important to figure out the sample size before you do the research, because the sample size will determine the margin of error. Remember, guys, the larger the sample size, the smaller the margin of error. The smaller the sample size, the more likely you're going to have lots of error there. So it's important to try to figure out how many should you survey so you can minimize, the margin of error there. How large a sample is needed in order to be 99% confident that the sample proportion will not differ from the true proportion by no more than 5%. So the 99%, guys, is the confidence level C. Can someone tell me what do you think E is here? He says he doesn't want the sample proportion, the proportion from the sample, to be different from the true one by no more than 5%. Any guess what do you think E is? 5% is. Remember, guys, the difference between the estimated value and the true value is the margin of error. So when he says he doesn't want the sample proportion to be different from the true proportion by no more than 5%, that's E. That's the margin of error. So he says you are allowed to make a margin of error, but no more than 5%. So you have to be close to the true value by within 5%, but no more. So that's E. Let's look at the formula, guys. He gives us the confidence level, which is 99%. So I think I know ZC, and a student told me earlier that CC here is 2.575. He gives us E. This is it right here. You need to change it to a decimal, guys. You don't write a percent in an equation. That's 0.05. So what else do we need in order to find N? I need a P hat and Q hat. It's an estimate for the proportion. If you guys, someone doesn't give you the probability, he didn't give me P hat and Q hat, what would be the best compromise? The probability should be as low as 0, as high as 1. He didn't give us the value. What would be a best value for P hat and Q hat, since they were not given to us? What would be a reasonable compromised value? I mean, you're fighting for 0, I'm fighting for 1. What's the middle ground for both of us? Any guesses?
50-50.
50-50, exactly. That is the correct answer. And that's what the book uses. The book says, if he doesn't give you P hat and Q hat, use 50%, 50% for each. No one will be upset. The success is 50% and the failure is 50%. So that's the compromise that you make. So your N, use P hat equals Q hat equal 50%. when those estimates are not given, are not provided. So now, guys, I'm ready to find n. You put 0.5, 0.5, and then ZC is 2.575, 0.05 here squared. Okay, and let me show you how to do that on the calculator. (0.5) times 0.5 times, open parentheses, guys. Put 2.575, divide by, be careful, it's 0.05, not 0.5, and then square it. There's the square right here. Right here. Okay, remember the sample size has to be a whole number. So the minimum sample size, you always round up. Round up your answer. Because 663 will not be enough because it has to be 663 and a little bit more. So round up your answer for sample size. This was multiple choice, guys. If you're doing your work online, you should select 664. That's the answer, 600, because I got 63 and something. Even if it is a 0.06, guys, you have to round up. And that's the answer. All right. Let's see. We got a couple more. There's another one with sample size. A state highway patrol official wishes to estimate the number of legally intoxicated drivers on a certain road. How large the sample, so how many he should pull over? A larger sample is needed in order to be 95% confident that the sample proportion will not differ from the true proportion by no more than 2%. So he wants his work to have only a margin of error of no more than 2%, guys. So that's very close to the true proportion. So that's C, and we agree, guys, that that's E. Okay, he didn't give me P hat and Q hat, so then in this case, I'm gonna use 50-50. State the value of the margin of error, which is 0.02. And can a student tell me what's the critical value ZC for 95%? You can type it.
1.64.
No, that's the 90%. It's the other one. $1.645 is the first one. What's the second one? The 95, guys.
1.96.
You got it. So ZC is 1.96. Exactly. So N, guys, will be 0.5, 0.5, 1.96 divided by 0.02 squared. Okay, and let's do that. Zero 0.5 times 0.5 times 1.96 divided by 0.02, and don't forget to square it right here. Okay, enter. 2,401 exactly. So no need to round, guys, because it's a whole number. It's exactly 2,400.
Mr. Bazzi,
Mm-hmm.
could you just, I think you already explained it. Why do we put the 0.5 if you said if something wasn't provided?
Yeah, he didn't give me P hat and Q hat, which is the sample proportion. If he doesn't mention them, you just use 50-50.
Okay, thank you.
No problem. I'm glad you asked. Now look at part B, guys. Repeat part A, assuming previous studies found that 75% of the drivers on this road were legally intoxicated. Now he gives you P hat. He says, well, we know from previous samples that P hat was 75%. And now, guys, you don't use 50-50 because he gave you the information. So if P hat, guys, is 75%, can someone tell me what Q hat would be? Once you know P hat, guys, you know Q hat.
25.
Yeah. Thank you. So now N would be 0.75 times 0.25 times 1.96. Nothing changes here, guys. It's the same margin of error. Okay, and let's see. You're going to have a smaller sample size when we know P hat and Q hat. So it will be 0.2575 times 0.25 times 1.96 divided by 0.02 and square.
I'm confused. How'd you get for Q hat? How'd you get 0.25?
Oh, this is the probability of success, 75%. The probability of failure will be the rest from 100%, remaining from 100%. So 100% minus 75% is 25%.
Okay.
Got it? Let me write it down here.
Yeah, thank you.
There you go. That's very important because this, he will never give you Q hat, guys. He assumed that you know how to do it. He will give you this, and your job is to subtract 75% from 100% to get Q hat. And that's what I have on the calculator. And watch, guys. Okay, what would be the sample size? Can the students tell me? Let's say that I give you this as a multiple choice question. Which answer would you choose? 1,000 and then what? 801. You have to round it up always. It's 1,801. You see, it's less than the previous answer. When you have a previous estimate of what happened, that you likely need less sample size, less people, just in the sample, which is 1,801. Okay, what I'm gonna do now, we're gonna do a lab tested 12 chicken eggs. So N is 12. Here's how you start reading, guys. So N is 12. So number one, we're doing a review now. And found that the mean amount of cholesterol was 246 milligrams. So X bar. Anything from the sample, guys, is called X bar. The population mean is called this and that. We don't know. We need to estimate that. We need to find an interval for that. 246 with S equals 11.7. Okay, guys, let me just make a comment here. He gives you a sample standard deviation S. Once he gives you a sample standard deviation, then you have to use T interval and not Z interval when you find your confidence interval. We explained the difference between the two on last time we met. We use Z interval when the population standard deviation is given, and we use T interval when the population standard deviation is not given, but S is given instead. And I even make it more clear, guys. I just put the letter S here. So I'm giving you a sample standard deviation. Construct a 95% confidence interval for the true mean cholesterol contents of all such X. I'm gonna do this one first on the calculator. And I'm just going to remind you how we did that by hand last time we met. Using TI-84. Okay, watch, guys. Very straightforward. All you need to know which interval, which feature to use. So you just go here. You go to Stat, Tests, And now you will start thinking, well, in this chapter, I learned about Z interval, I learned about T interval, and I learned about one more, which is one prop Z interval. Here's, guys, how I can make decision to which one I should use. I look at the prop. Well, I say this says proportion. That's not for mean. So then that should be out. Then I'll go back here. And then I said, is it going to be Z and T? And I said, well, the instructor says when S is given, we don't use Z, we use T. Because look, guys, if you use Z, watch what happens. It's asking you for sigma. And I didn't give you sigma. I didn't give you sigma in this problem. But look, if you go to stat test again and put T interval, look what happened, guys. It's asking you for S, which makes sense because I gave you S right here. So it is S. Now input, if he gives you the data set, the raw data, you use data. If he doesn't, by default, leave it at stats. So X bar, watch, guys. It's going to be very straightforward now. 246. S is 11.7. N is 12. Confidence level, what was it? 95. And calculate. And here you go. That's the interval. Mean, you write it like that. Mean is between 238. Let me make it one decimal place. 253.4. And how do you interpret your answer, guys? You say with 95% confidence. You can say, or we can say, that the true mean, cholesterol content of all such eggs is between 238.6 milligram and 253.4 milligram. That's using technology, guys, and we're done. So all you need, guys, to be able to identify, do I use a T interval or a Z interval right here? Okay. You use T interval again when he gives you S. If he gives you sigma, population standard deviation, you use Z interval. I have a student ask me about this. So T interval is S. Now, how do we do this one by hand? You put mean is between X bar minus E and X bar plus E. And you should have the formula for E, which is TCS over square root of N. That's the formula for E. S is the sample standard deviation. That's given, guys. N is the sample size. That's given. TC is the critical value, but he gives us the confidence level, which is 95%. How do you find TC, guys? I showed you on Monday how to do that using table 5. And watch. So what's the sample size? 12. And what's the confidence level? 95%. Look, guys. There's the table. That's a 95%. Here it says degrees of freedom, which is the sample size minus 1. Since my sample size is 12, 12 minus 1 is 11, guys. So I just go to 11 right here. And then go to 95 and see where the two meet. They meet at 2.201. As you can see, guys. Ignore those two rows here. That's for chapter 7. Just confidence level, 95 and 11, 2.201. So I'll just go here. 2.201 times S, which is 11.7, divided by square root of 12. Let's do this together. That's the algebra we practiced last time, guys, and how to do use the square root. So 2.201 times 11.7. Okay. Divided by square root of 12. I got 7.43. Okay, guys, we're done. Once you find E, you do X bar minus E, and then X bar plus E. X bar is 246, it's given at the very beginning. 246, guys. Minus 7.43. And X bar 246 plus 7.43. And guys, I'm gonna get exactly the same number as above, 238.6 and 253.4. And that's the confidence interval. Okay, so that's how it's very easy to do it by hand if you just have the table. So for TC equals 2.201, U is degrees of freedom equals 11, and C is 95, and table 5. Okay, so that's number one, using a calculator and using technology. Second one, we're gonna use technology only for this one because it's raw data. Raw data, guys, just use technology. A college math professor has office hours from 9 to 10:30 daily. A sample of waiting times to see the professor in minutes are given below. Assume that sigma is 7.84. You see, he gives you sigma. You must have a Z interval here. If he didn't give me sigma, guys, I just use T interval. So sigma, find a 95% confidence interval for the population mean. Okay, let me pause for the second, guys, until you enter the data into L1. So if you can work with me and put the data in L1, and then we'll come back to it in 1 minute.